Hi, everyone. This is the second of two videos going over how to, first of all, make a part that's ideal and convenient to translate into a drawing, and how to properly do a drawing given the part. So last video, we made the part from chapter 10, hands-on test drive number 1, that is this part right here, from hands-on test drive number 1, which is this picture. So this part from the book, if you don't have it, again, I highly recommend you get the book. It's a really good reference, and there's a lot of practice problems in it. And you'll most likely use it in the future if you do plan on designing and 3D printing, for example, different parts and devices even. So let's go back into our Word document. So we also show the approaches, again, how to make the part so that it translates easily and nicely to a drawing. We also added some properties from last video. So this video will show you how to automatically have them automatically propagate in our drawing. In this video, we'll also make and edit the drawing template, which will be uploaded which will be uploaded for you guys' use. We'll also go over how to make a good drawing, and that includes proper approaches and labeling techniques. And lastly, we'll go over how to add text, change text, add shapes, and again, add the properties from the first video. So you can actually add them manually as well. It's up to you guys. I just think it's fancier if you just had them automatically propagate and change as you change your model, instead of having to go back in and change the numbers every single time you make a new iteration of your part model. So let's start by making and editing our drawing template. So I already have it because Milton already sent it to me, but you guys will eventually all have it as well. Let's go into my folder, and it should be this thing that says in all caps, custom drawing template. Let's double click on that. All right, so this one already has actually saved this by accident, but let's just pretend that this part wasn't there in the first place. So yours won't come with a free part model, unfortunately. Let's delete this. Yes, I want to delete. So now you have this sheet. Drawing templates come from existing drawings. Drawing templates are basically normal drawings without any parts on them, without any numbers on them, just the blank drawing. A blank drawing can be then made into a template by just saving it as a template file type. And I think I showed you guys how to make a part template in one of my previous videos. This is a very similar idea here. So I don't know why it says quit. Oh yeah, okay. Let me resave this. Okay, there you go. Control S, this thing disappears because now it's not associated anymore with my previous parts. Material no longer here. Finish also not here. Okay, so first of all, there's essentially two layers to this drawing template or drawing environment. The first layer is what you see currently. It's basically editing the sheet. It's just editing the sheets without editing the sheet format, I believe. Yep. So editing the sheet means you can add on different shapes and part models, but you can't touch any of these pre-existing lines. So first of all, to start, this is a note block. There's two blocks usually in a drawing. These are the different sections. So 1, 2, 3, 4. You can more easily tell that which section you're referring to, like 4A, for example. This is a title block. title block will have, let's zoom in a little bit, your sheet scale and your sheet number. Typically, you won't need to change this too much. The sheet number, I haven't really used it, but I guess if you want to make multiple sheets, it's up to you as well. If you want to add multiple, add a sheet, for example, it will change this number here to like 102, 103, 104. I don't see the need for that essentially. Drawing number, revision. So what I meant by iteration, actually, I meant to say revision. So the first, once you revise your part model, that becomes revision number 1. So before you change your part model, make sure to resave as under a new name. So if your first part model was, I don't know, like part 1, right? If you change it, you want to change that name to part 1 V1. That way, when you make changes to it, you get to keep your old file as well as have a new revised file. And that applies to drawings as well. Once you finish your new part, it's best if you make a new drawing from that and make that revision number 1. So you keep your old revision, which is, I mentioned in the last video, should be revision dash. You make the revision 1, 2, and 3 as you make more, etc., etc. This is where your drawing title goes. It basically takes the file name and the file name of your parts and put it right here. Again, here are the different names and initials you can put in for who does the modeling. There's a typo here, but who does the modeling, who's doing the drawing, who's doing the analyzing, and who checked it, put initials, dates, and then you can check either inches or millimeters. But again, you can't touch these in the sheet editing environment. So we're currently in the sheet editing. In sheet editing, we can only add further shapes or notes or views and part model views. We can't touch any of the pre-existing, I guess, like pre-existing lines and the architecture of the sheet. So before you even start, you can change various things about the sheet itself. In the sheet properties, you can change the scale as well as other aspects, such as the name of the sheet. But most of these will stay the same because you're already using a sheet template, which means most of these are already set for you guys. So you don't need to touch any of these pretty much. All you really need to do possibly is change the scale. So just change the scale and then you're done, because we're using a custom sheet size and custom sheet everything. So if you want to change the scale, you can do that there. So that is the sheet editing environment. Now there's also a different thing, a different environment. If you right click anywhere on the sheet, actually anywhere within the environment, there's an edit sheet format environment. So that changes what you can do in this. It changes what you can do to the drawing. So you no longer can really place down any models because you're editing the sheet itself as opposed to adding things onto the sheet. So now you can see that when you hover over different components, when you hover different parts of the sheet, it will be highlighted, which means you can change them. But we don't typically want to change what's already there because, again, most of it would be pre-made and ready to be used by you guys. However, there are a few things that you can change and should change. For example, if you go into here, so it's a little messy, but Sheet. All right, give me 1 second. This might not be the right drawing template that will be given to you guys. All right, let me pause the recording real quick. I'll be right back. All right, I'm back. So I double checked, and this is the correct template that you guys will be given pretty much. It's either this or something very similar to this. But either way, I'm going to show you how to, a lot of the concepts will be the same regardless. So let's start by, what I like to do before we even start is to just come down here. So you'll be given these two boxes. Unfortunately, you can't like double click to check them or to select one of these two. What I do is go to sketch. Again, if you sketch in the sheet format editing environments, you can't interact with them once you're putting down your parts and your part views. So make sure to keep those separate. When you're editing the sheet format itself, edit the sheet format, not the parts. Actually, you can't edit the parts in that case. And when you're editing the parts, don't touch the sheet format. Leave that be. Don't touch any of these. You most likely can't, but don't try to like, don't add the mass, for example. Don't add the mass when you're putting down your different part views. Add the mass, if you do want to add the mass or change the mass in the sheet format editing environment. So the environment we're in right now, where we can change the different lengths and stuff. We can change different parts of the sheet format itself. So before we even start, I could just put a cross, double click over what unit my document is in millimeters. So that's what I prefer to do. You guys can do this later on or in a different way, use different shape. I prefer X's because it's nice and clear. I think you stick with X's as possible. So what you see here with these number signs, these are the links that SolidWorks uses to link your material, your finish, or your mass, the weight from your properties document. From your part properties, which we set last video, which we had set last video. So in this case, it's sort of messy. But if you double click, it's easier for us to tell what it is. Okay. So first of all, I think it's easier if we just, so here you can see there's a leave button, right? If you click that, you get booted out of the sheet format editing environment. So let's start by just putting down the part that we made from last video. So you double click this. It's nice if you had made it, if you made it with the orientation in mind, you can just go ahead and make a multi-view. If you just need 4 views, you just click these. If you need more, you can always add more. But for the model we made, we only really need 4. So currently we're using sheet scale. If you use custom scale, you can, but then you'll have to just change that sheet scale real quick. So it reflects the part views you used. So you shouldn't have like a 2:1 scale for the views, but have it labeled 1:1, as that will cause a lot of confusion. Well, some confusion. So once you're satisfied with the placement, you can always adjust the placement later on. Click check. Ta-da! Nice. So it looks very, very nice. If you adjust the shape here, it pulls on both of them. So if we had to add an extra view or two, we might have to change the scale a little bit to make these smaller. In this case, we're fine. And for this isometric view, it's good to make that a little bit fancier. White is not the best color here, but usually you can make that, you can set this view here to either of these two. I prefer the shaded. This is not the best color for shaded, but we'll just stick with that. It doesn't matter for now. Okay, side view, front view, top view. Nice. So as you can see here already, it's very nice. Some things have already automatically propagated, such as the drawing title, chapter 10, hands-on test ride number 1, as well as our material PET. Perfect. So we're missing a few things here, and that's because if we don't name it properly, and being the prepared person I obviously did not look at the names here first before I made my property names. So therefore, SolidWorks does not know that we even had these properties created or labeled for our parts. So it cannot propagate something that it cannot find. Essentially, it cannot find the name that's already been set to them. And I'll show you how to set them later on. Let's first actually do some dimensioning and finish dimensioning all these components, and then add some text to them. So it's a good idea in general if you just label what view it is. You can do that by going to annotation and notes. Basically, where you can find dimensions, go over a little bit, you can find notes. Later on, you'll also use balloons as well as tables, but that is for a future video or a future date. So let's start by dimensioning. Actually, let's start by just adding some center lines. So use center lines when obviously sort of intuitive and obvious, but when something is symmetrical. So in this case, our shape here is symmetrical here. Now shape is symmetrical about here as well. We basically, yeah, okay. So what this means is that essentially now, it's basically saying anything that's labeled, if I only dimension, let's say, this distance here, escape. If I only dimension this distance here, check. If you have these center lines, people will know that, oh, this is reflected over, which means this distance here is also 6. So you don't have to label that anymore. If you don't use center lines, you have to label that. It gets really, really messy really quickly. So use center lines whenever possible first. So start by putting down center lines that you might use. Another rule of thumb, actually, it's very important. You want to maximize, you want to pick a view that you think you can maximize the number of things you can dimension. You should put most of your dimensions on one view if possible. So you do want to spread out your dimensions equally on all 3 views. You don't want that. You want to hopefully be able to, ideally, you want to put all your dimensions on one view and have it be clean and organized on one view. But oftentimes that's not possible. So 2 or 3 views, maybe most dimensions go onto this view, and then some go on here, and then like 1 or 2 goes on here if you really, really cannot fit them or find them in the other views. Also, this is very important, very important. You should not put dimensions on the isometric view. It's just a big no-no, and points will be taken off if you do that, I believe. So you do not want to label this. You want to keep this clean and unlabeled. Okay. So let's finish the rest of our labeling. We can take some advice from the book. Let's see, center mark. So perfect. Smart dimension. Let's mark this in our circle, let's see what our reference drawing has. Okay, so it's labeled this outer circle. So this is the dimensions you will use if you have a hole, a certain type of hole. In this case, it means 4x. So first of all, it says 4x, and then that symbol there is a diameter symbol, 4.5. And because we checked millimeters, it's 4.5 millimeters. You don't have to add the millimeters part to this. The whole thing is in millimeters, unless given a different symbol at the end, like a degree sign, degree symbol, through all, and then little angle symbol, diameter of 8.96 times 9 degrees. So this is the labeling for a chamfer. Basically, how can, this is like the easiest way to tell people that you could have used the chamfer here. And this is actually a the result, possible result of a chamfer. That's that results in a outer diameter of 8.96 millimeters and a chamfer being 90 degrees, being 45 degrees. So chamfered across 90 degrees, giving you the chamfer angle of 45 degrees, if that makes sense, hopefully. Let's do that. For x means there's 4 of them. For x, diameter of 4.5. Again, if you had put a center line here, you don't have to label 6 over here as well, and 7 twice. So, so drawing here is not perfect as well. You want to be slightly more detailed than what they have here. But this is good though. 4x, diameter of 4.5. Let's do that. Your arrows might look different than mine, but that is a-okay, because there are some different drawing standards that use different types of arrow appearances. So let's double click on that. Oh, okay. So if you want to edit this text here, this is how you do it. You double click, make sure it's highlighted, 1 click. And this dimension, this properties table will come, properties tool will come up, really. Property manager will come up for the dimension. So here, mod dm is the diameter symbol. So if you delete this, the symbol goes away. You don't want that. You want to keep that mod dm there. Okay, let's see what else they have. So it goes from mod dm, no spaces, to dim. Dim means dimension. That's 4.5. If you delete that, oh, you can't delete that because that, like, why dimension it if you don't have numbers there, essentially. So then here are the other symbols you can also add. This is the one we'll use later on to countersink. It's not chamfer, it's a countersink. I didn't know that either. So there are other types of symbols as well. So they actually used a countersink hole. This is not for chamfers, this is for countersink. But I mean, they can't really tell though, because it looks the same once you've completed your part. Countersink holes look like if you had extrude cut, and chamfered the edge. So essentially they're the same thing, but this is a good symbol to use, and we will use that shortly. And then I want to use, if you want to add 4x, which you should, 4x just means there's 4 of these circles. Okay. 4x, there we go, right here, it comes up. 4x, 4.5. Don't worry about tolerance and precisions as of now. We'll talk about that in a future video or in a future lecture. So four times the circles of 4.5. And also add through all. So through all, basically, you can either use through, I believe you can use through all. You can also use actually, yeah, just stick with those, through or through all. That means the circle that you labeled here goes all the way through to the bottom. So this hole here goes all the way to the bottom. It doesn't stop in the middle or a certain distance into the object, into the part. Okay. So on top of that, if you hit enter, you can go into the next line. So on the next line, you want to hit the countersink symbol, hole sink. So that's a symbol that you want. So once you get the hole sink symbol, you then want to add on your extra dimensions. So we did hole sink of 8.96 diameters, a diameter of 8.96. Okay, let's see what I'm missing. And then add 9 degrees. X 90 degree symbol. Make sure, okay, let's put a space in between 90 and X. So again, everything that is shown here will be in dimension text box here. What are these two? I wonder. Add parentheses. Okay, so we don't really need. That's one other thing that you have to do. If you add a dimension, if you over dimension, first of all, you shouldn't over dimension. But if you want to add an extra dimension, that will make it easier for you to figure out how to make a part. You can make a reference dimension, which basically means a dimension within parentheses. Essentially, that's how you tell people that the dimension you're given here is an extra dimension that can be figured out using, if you just do some math using other dimensions that already exists on the drawing. But if you want to make life easier, because you want to make life easier, you added a reference dimension, but make sure to put it in parentheses. So put reference dimensions in parentheses, just like how reference dimensions in your sketch becomes grayed out to prevent being overdefined. Once you're done with that, it looks a bit weird, but it should be fine. All right, cool. So that's that. Times 4 means it goes all the way around. And that's how you notify people that you have 4 countersink holes of this dimension, which goes all the way through. Now, let's make some other, finish up dimensioning. 7. If you put 7 millimeters here, you don't have to put it over here as well, and over here and over here, because again, assumed symmetrical due to these center lines. One other thing you can do, if you don't like the arrow positioning, you can click on, excuse me, this blue dot here, and it'll change size actually. If you just click on the arrow, you can change whether these arrows are on the inside or outside. So that sometimes helps with organizing and making things look nicer. So maybe I want this to be on the inside and this to be on the inside as well. Not this one, probably. This one looks weird. Outside. There we go. If you can fit on the inside, I guess inside. Again, it's a preference thing with these arrows, and it's about how you want it to look and how clean you want it to be. Okay, let's see what dimension is missing. I've chosen this one to add most of my dimensions. So let's do that. Let's add this dimension here. 1, enter. Let's add this width here, 42, enter. Okay, so you see how like these two dimensions overlap and can cause some confusion? You don't want this to happen. This is a big no-no right here. You want it to, basically you want to be able to, if you were just given this out of the blue without ever seeing this object, without ever seeing or having the part model file, you want to be able to recreate every single bit of it. And essentially drawings are the main form of communication, right, between engineers. So you want to make sure everything is organized, everything is dimensioned, everything makes sense and can be easily followed. So if you don't want this overlap, it's best if you delete that and spread things out better and make it easier for other people to follow. So in this case, you can just put the same dimension right here. It'll convey the same information, but now everything is separated and spread out, easier to follow. Let's dimension this as well. Let's hold this up a little bit so we can see the period. Okay. And let's pull this out. Pull this out a little bit right here. Get rid of this 6, move this 6 somewhere else. I'm going to move it down here. Pull this 42 down a little more. All right, looking very nice. Let's see if I'm missing anything. So for example, if you want to dimension this length, first of all, you don't really need to add extra dimensions and add extra reference dimensions. It just makes things more complicated. It is relatively simple. For example, the distance from here to here, right? You don't really need to label this dimension. It's an extra dimension. You can figure this out. I don't know why it says 19.59. Sometimes it does something funky like this. Oh yeah, I need to show you guys how to make the template, huh? I'll do that at the end. I'll show you guys how to make a template. So yeah, before I finish, I'm going to show you guys how to make the template file. It should be pretty easy. If you watch my previous video, you likely know exactly how to do it already. But make sure to make this template file. So when you hit new document and go down here, you can find like my custom template. Just click on that, and this template will come back up. So essentially, you get the same nice starting point to start your drawing. So before I finish this video, I'll quickly go over that real quick. Okay, let's see if we're missing anything else. Oh yeah. So you don't need to keep these extra dimensions in here. Like 10.2, it can be assumed. If this is 20, this is 1, and this is 1, that 22, that this length here, excluding these two, that this length here, just by looking at the other dimensions, you can tell that this is 10.2. 19.6. Wait, that dimension is not right. Let me go back and change that real quick. It's bothering me. So go back to your edit. All right. This radius should be 14. Oh, okay. So it doesn't tell you what that distance is. That's why it's so funky. This is just a poorly designed part model. I could have done better. Anyways, so that dimension is correct. Rollback state. Oh, okay. So if you start editing your part model, you can't use it. You can't simultaneously edit dimension it as well in the drawing. So make sure to, that's what it means by rollback. Make sure to quit out of all different environments and save your part model. Make sure it's just in its normal viewing environment before you go back into your drawing environment. So it can propagate properly. So Control S. That is very weird. There you go. Some visual glitch. That's very annoying. I bet if you just close this entire, don't save. If you close everything here and open it again, all the drawings should be there. Yep. So it's just a visual bug. Don't do what I did if you want to save this trouble, save all your trouble. Make sure you are confident your drawing is correct. But it's always an option to go back to your part model and change something minor, and then finish up your drawing. So as I was saying, because this is 19.6 and this is 1, the total is 21.6. The result is that by doing the math and getting the difference and then dividing by 2, you can figure out the distance from here to here. So this will be an extra dimension. On a test, we might give you this, but in the parentheses, just to tell you that, hey, this is an extra dimension. You don't have to have this labeled in the drawing as well, in the part model environment as well. You don't have to have this dimension. It's just for your reference. It's called reference dimension. So we don't really need that. Actually, let's keep it in. So as an example. Okay, so I think we're done with this perspective. We're still missing a few other dimensions, such as, how tall is this, right? We don't know that. What's the diameters of these circles here? So we'll have to go on to this different dimension, different view. So we want this to be 12. And in this case, we also want to go into the text and put in through all, so they can tell that this thing goes all the way through as well. You don't need to show hidden, whole lines. There's a way you can put in like whole, hidden lines for holes. You don't show hidden lines for holes. You can just do through all. And I think you should just do through all. So you don't need to do all of these like hidden lines here. Those are extra. I think it makes it messier. I think that's the reason why you shouldn't do it. So you want to add this through all. Let's see. What does it have? So yeah, it's missing that here through all. It also has a detailed view. Okay. But let's just add a simple dimensions for now. So through all, this thing here, dimension, this thing here. So what this is essentially, first of all, I believe you don't need to have a center line here. Actually, let me double check. Yeah. So if you add a center line here, that'd be way too confusing. So all you need to do is just add a, if you have a, let me get rid of this center line. Hello? Delete, there you go. If you had the circle center mark, you should be fine. People can assume that these two are symmetrical. If you add another line down the middle, it becomes very, very cluttered. And basically, you don't want to make it more confusing than it has to be. So 21 here. You can do the same thing as you did up here, because this is essentially like a counter, some sort of counterbore hole, right? You can do counterbore spot hole, something like this, to indicate that, oh, this is not just a regular hole. There's a little area for you to hide the screw head, for example. You do that. You add a diameter of this, which is 21. There should be a way actually to just never mind. Here, it's easier if we separate these two actually. Separate to make it cleaner looking. So click the outside, down. Scroll down here to here. Any counterbore hole spot. 21 millimeters in diameter. And let's see what we have up here. Times 90 degrees. So this indicates that it's the shape. So you don't need to add a degree at the end. I mean, honestly, sorry guys, I'm gonna actually move this back into me. Get rid of this dimension. I'm gonna put it back in here. So it's all grouped up actually. Nice, more practice for me too. It's a little bit rusty, you know. It's been a while, so I have to make a drawing. Okay, there you go. That's good. Okay, now you just need to mention some of the edges you didn't get to, such as this. 16. Just want to do this. 8. We can do something like this. 25. If you should add an angle here. Oops. Click edge. Click edge. Add an angle. Oh, wrong edge. Let's click this edge here. There you go. 35. 135. And same here. They used a detailed view, but I don't see a need to here. You can just do this. 35. Make it nice. Again, you can change the direction of the arrows. I believe you can also change where these lines go. So let's redo that. I'm gonna get 45. 45. And 45 here as well. Hello? Whatever. Okay, 135, 45, very similar. Close enough for me, honestly. I won't complain. Make it look organized. All right. Nice. Very pretty. Okay. So let's also label this, just radius of 14, and then label this as well, which is 10.2. So here, I have 10.2 here already, so we don't really need to have this dimension here. So yeah, make sure to check and make sure you don't have duplicate dimensions. Those are unnecessary. So for example, we don't need a dimension from here to here because we already have it in this first view. I think this 8 is fine. I think that's extra too. Might be useful though, so let me just add that as a reference dimension. I think we're mostly done otherwise. Oh yeah, at the bottom here. Tisk, the terrible model. This is 12. This is 25. As you can see, it's getting a little bit cluttered, just a little bit cluttered. Okay, and let's get this here. We actually want to get this length here as well. What the heck? Let me get rid of this one first. So I think we organized and we organized some stuff to make things less cluttered. Move this up, clear some space, make some space. Move this over maybe. Actually, this is fine. Be in the middle. Just need to change these two arrows. Okay. Label this. Okay. And lastly, label this as well. Okay. So there's some overlap with the arrows. It's not ideal. Change it if you can, but if you cannot, it's fine too. The goal is just minimize overlap of arrows and lines. So so people can very easily tell, like, oh, this is the angle of this of these two lines, and this is the height of this area here. Like, you wanted to be able, you wanted to make it very, very easy for whoever's looking at these drawings to recreate the part, because hopefully one day manufacturers will use your drawing will use your group's drawing, your team's drawing to make the part. And if you don't have accurate and easy to tell dimensions and labelings and labels, it becomes very confusing and hard for them, and they might do it wrong, and you don't want that to occur. Make it look all nice and stuff. I think we're mostly done. Yep. Okay. I think we're more or less done. So the good thing about all these dimensions is when you drag your view, hello, double click, make sure the move arrows appear before you drag them. Okay, when you drag your views with you, all dimensions stay in place. Now, let's add some notes. So you can always add notes to your drawings. I typically use notes to just label the different views. So this is top view, right? Like, double click. You can change the font size here. Let's make it 18. Let's see how big this is. FFF. Okay. This is still 12. Hello. 18. That's pretty good. Let's make it bold. Okay. Top view. And change back into 12. Nice. Top view. Nice. And then click it 4 more times. It assumes that if you're making one annotation, you're making multiple annotations afterwards. So you can click again somewhere else and bring up the same font and characteristic of your initial, and other characteristics of your initial annotation. So in this case, we want to do front. All uppercase is a great idea, honestly. It's harder to misread uppercase, to misinterpret uppercase. And then side. You can always double click to go back in and change this. And the cool thing about, you can also set different colors as well and other things like italicizing or underscore, but I don't think you need the other ones. Well, you won't need to use them that frequently. So the good thing about having these annotations is that SolidWorks knows when it's coupled to a view. So let's say this view is moving, right? You can couple this to this view, I believe. Couple this to this view. Hello. All right. Maybe not. All right. Okay, that's very weird. Usually allows you to just, I think that's so weird. Okay, so I used to be able to just drag it near the view itself, and once it finds the outline of the view, it can attach this annotation to the view. So when you drag, it drags along with the annotation, drags along with your view. Oh, see, the side view worked. What the heck? What the? Okay, you might have to make it. You might have to start by attaching it. Wait, let me check. Hit that. Control C, Control V. Okay, let's see what's unique about this thing. See, it's connected. When you click on the side view annotation, it outlines the view outline. It also selects the view outline. So you can connect these. I know you can, but just getting it to work now. It's being shy. Come on. It's one of these options, I bet. Tech format leader. Parameters. This one of these, maybe. Okay, you might need to make a new. Let's restart. Make a new note. So So I think you just have to, if you have to start by bringing your clicky option, the click option, click within the shape. So do you see how the purple like bounding box appears around this top sketch, top view? You want to make sure this box appears, this purple box, pink box appears before you click, but make sure the arrow isn't there when you click. You don't want the arrow. You just want it to be associated with that box. So now do top view, Control A, keep the font type bold. So now when you drag this top view around, it moves with it. Nice. Sweet. Okay. Okay, so make sure to associate it before you start typing because I screwed up twice now. Oh, 3 times now. Perfect. Get rid of this. Control C, escape, Control C, Control Z. Sorry. Make sure it's within the bounding box. The purple pink box appears. Click front view. Bold. Change that into font 16, I believe. No, wait, it's 18. Again, I'm just being really picky right here, but I do want this to look nice. So, and if you have time, you should always aim to make your drawing look nice. Nice. And the side view is already associated, so it doesn't matter. You can drag this to the side somewhere. Pull this up a little bit. There we go. Move this. So you can move the isometric view independent of the other 3. What the heck? Other 3. But when you move this front view here, because the front view is considered, actually the side view is considered the main view, but because this view for our purposes is the main view, this front view here, due to the way we oriented this part, both of this top view and the side views move along with the front view. So it stays like organized. And you know this is a projection of the side here. And this is a projection, this top view is a projection of this top here. So nice. Nice. So I think we're pretty much done with labeling and dimensioning. Let's hit Control Save. So again, just to show you that once you're in, if you're in the sheet editing environment, you can't touch anything that was edited in the sheet format. So the cross we did earlier, you can't do that unless you double click the box, I guess. Excuse me, unless you double click. Then you temporarily enter the sheet format editing environment. Check. So normally you can't change any of these. This is a little misplaced. This title here is a little bit misplaced, but you can change that later on. So yeah, those are the key points and approaches and tips regarding proper drawings. I think I covered most things here. Let me just double check the Word document. So we're gonna go over this next. Discuss how to add materials and scale titles, revisions, and drawing numbers. We did this already, and center lines and dimensioning approaches. We also did this, font size with dimensions. Actually, we have not, but should I change font size with dimension units beginning of. Okay, so we can change the font size here as well, but I believe you can't do it here. I usually haven't found the need to. That's why I don't really know. I'm trying to figure it out right now. I believe you just go into settings. And we do size, annotations, notes, drafting standards, annotations. So, okay, if you go to document properties, under drafting standard, there you can find you can change various parameters, I guess. I've never had to touch any of these. I'm usually satisfied with the default. The template usually does a pretty good job of, like this, the font that's already present is pretty good, I think. So I don't think you guys will need this too frequently as well. But if you do though, it's all in here somewhere. You can change the line thickness, for example, the arrow type, the base diameter dimensioning standard is usually ANSI. Based on different standards, you get different like styles of arrows and labels. But we don't have to bother with that too much right now. We'll go over datums later on in a future video. Notes. Font. It's definitely in dimensions. Font. There you go. Okay, so I guess you can change to use a larger font if you like. So using unit, you can use points, 14-point font, units. We want like a larger dimension sample here. If you want a larger dimension. Oh wait, these are heights. I don't think I want to change this. I want to change. Yeah, no, I think it is the heights. So let's try 16. Okay. Now all these are larger. So Control Z. Oh, whoops. Control Z doesn't change that, huh? So I have to go back. Yeah, I usually don't play with this too much. I'm satisfied with what I'm given, I guess. I'm an easily pleased person. Easy to please. Okay, go and document properties, dimensions, font. Let's bring it back down to like a reasonable, I believe it was this by default. 3.175. There we go. And that should be fine. Nice. And the rest is editing the sheet format component. So we're done with the sheet editing. We're done adding our parts. We just have to add the other components, such as like the finish, the mass, the name, the iteration, the revision number, sheet scale. Oh, sheet scale is 2:1. Okay, guys, so I guess it changed the sheet scale, huh? So right click. Sheet, nope. Edit sheet. We can toggle back and forth between sheet format and edit sheet. Edit, as you can see in an edit sheet format, you can't edit the parts anymore. You can only edit the components of the sheet. So let's go back to edit sheet. If we go into settings, go into drawings. Huh. I forget we can change the scale. You can always just look it up. It's honestly easiest. Oh shoot. Actually, there's an easier way. It's just down here, I think. Yeah, okay. So you can change your sheet scale down here, 1:1. 1:1. Control save. Oh, okay, there you go. That was 1:1 for some reason. Okay. Oh, okay. Now it's changing. What the heck? this thing was not changing along with my clicks. I felt. So 1-to-1 is like this. We don't want that. It was at 2-to-1 previously, so let's change back to 2-to-1. Ratio of 2-to-1. Being underdefined in the drawing is less important. Because it's harder to get every little bit, and it's like, what, underdefined? Wait, hold up, underdefined. Okay, so my part model is fully defined. Okay, yeah, I should be fine. I should be fine. I guess they're very particular about certain things. Like they may want like all views defined or something, but as long as you know that everything is fully defined, it should be okay. Like you maybe could miss like 1 or 2 minor dimensions. Obviously you can have that. That's why you have other people check it for you, check your drawing to make sure you get all the dimensions in. But as long as you feel like you can get all the information down, it's okay, because there's also center lines that the drawing environment doesn't take into account. These center lines, the drawing does not know. This drawing does not know that the center line basically reflects all of these dimensions. It may want all of these circles to be fully defined in order for this to show that it's fully defined. So just ignore that part on the bottom. Just make sure you know all the required dimensions are defined given the center lines and the center marks. I'm gonna try adding the center line again just to make sure. Yeah, it's too messy. I don't think this is necessary in this case. It's assumed. Oh yeah, it's assumed here as well. If you had added a center line here, it'd be redundant because, again, the top view already shows that it's already symmetric. So from here, you can assume that this view is also symmetric at the middle. So the center line should go all the way down here. You can imagine that basically. I might actually finish the rest in the next video. So there's actually going to be a third video, maybe. Actually, screw it. Let's do all this right now. What's next? Okay, so once you're happy with the sheet format, usually all these will propagate, but you still need to add a few things down here, and then you control save, and then you're done, basically. That's how it would normally go once you've understood what properties you had to make, or once you've added all the properties, all the parameters, you can then save and then you're done. But let's show you guys how this will be done. Edit sheet format. Okay, so let's go to here. So we can toggle everything. All right, here it is. So there's a box here already. Let's see what, basically if you want the box to link to a parameter, to a property you set in your part modeling environment, there's a link to property call out button, radio button you can hit. So you select you make a box. It's so weird. showed up previously. All right, give me 1 second. I'm gonna pause the recording. I'll be right back. All right, I actually made a really big mistake. So I was actually making the part drawing in the drawing template. So what you guys will be given is a drawing template. Don't make the mistake I made, because it's a very big mistake. Essentially, you shouldn't make your part drawing on a drawing template. Drawing templates and part drawing should be separate. So as you can see, these are part drawings, I believe. All part documents. Huh. Usually it tells you what it is. What happened? Okay, Chrome. Drawing document. Oh, no, it's fine, it's fine. Okay. So let's open a fresh custom document. So you won't have this. You won't have this issue. You get a clean document like this. Okay, so before you even start, I should have done this first actually. ASC format. Okay, now everything is here. ASC format, the weight, finish. Once you put in the parts, all these disappear. So you want to make sure that all these are here before you you want to make sure that these property names match up and everything's in the right position before you put in the parts. So this is material, finish. So these are already pre-linked. Let's see what they're linked to. Finish, weight. That's a little weird. Sorry guys, I did not make this, so I'm trying to get a grasp of this. Name. Okay, so I believe we just have to go into our properties and change the names of a few things, so everything can propagate correctly. Because as I was saying, if the name is incorrect, it's linked to a non-existing variable, non-existent variable, so nothing's going to show up there. So let's, whoops, sorry guys. For some reason, this is not cooperating with me. Oh, lag. Well, what the heck? Oh, annoyance. Somewhat annoying. Okay. Cool. So let's go back into our part. Go back into our properties. So again, these has to match. So file, properties, material. So this was recognized by the drawing. So this, if you look at our previous drawing of the model, the PT did show up. Here, let me show you right now. So this is evaluated value is PET, right? If you go into our drawing PET, so it picked up that one, but not the finish nor the mass. It did pick up the drawing title, however, which is just the name of the file, chapter 10, hands-on test drive 1. So we want to, okay. Oh, where did everything go? Where did everything go? So it's all here. Is it suppressed? Oh no, it's because we're in the, oh, it scared me. Okay, so it's because we're in the sheet format editing environment. So you can't see the parts. So if you just leave this, there you go, all the parts reappear. Oh, scared me for a second. I thought it deleted everything. I was worried. Got worried for a second there. So going back to our part model, file, properties. We're gonna have to change a few of these names. Okay, so this currently weighs 44.76 grams. This should show up. I don't get why it isn't showing up. Material mass, maybe. Does that say weight maybe? Weight and finish? No. Changes to revision. Mass. Try that. So surface finish, we can try finish. And we can see if that does anything. Okay. Control save. You gotta save in order for everything to be to like refresh, for it to link. If you do it correctly, it should propagate. Ah, there we go. So the name has to match. Nice. So finish gold plated mass for 77.76, and there's an empty box here for you to manually enter the mass. So once again, what I did was I went into the sheet template and made sure my property names matched these property names. You can always change these, honestly, I believe. You cannot. Okay, so it's pre-linked, pre-named. So to make sure the names match material, finish, and weight. Same thing down here. Let's check if revision also. Revision, okay. Part no. So you want to have this name down, have this name down. You can also have checked by, engineering approval, drawn by, author. What does this say? SW author. Okay. So yeah, you can have these self-propagate if you want to. Alternatively, you can also just add a note. So I'll show you how to do that in a sec. And honestly, it'd be easier if I just do this in a separate video, because this video is going a little bit long. So I'll finish up in a third video, unfortunately, because this might take a little bit. I think it's better if it's separated into a different video, showing you guys how to edit the sheet format and other ways to approach this, to link it, and what you should do. Huh. Ah, screw it, actually. I'll just add some watermarks in the video so you guys know where to go. We're already too deep into this. Okay, so gold plated for 44.76. You can add a G to the end of the. You can add a G to the end if you would like. Double click, space G. How do you do lowercase G? Okay, unclick all uppercase G. There we go. And ta-da! Get rid of this. There we go. And that's your note block completely filled out and correctly filled out. You can also add notes here if you like. Double click. Notes unless otherwise specified. There's a space missing, but you can add some notes here if you would like about this sketch. You can increase the space here always to add more notes. I didn't have to really use this either, so I just left it usually. Scale, sheet. So these two you don't touch. It'll automatically change with the page properties. So if you do 1-to-1, this will change. And if you add an extra sheet, this will change. The sheet number will change as well. So don't worry about that. The millimeters, we added that previously. You can always change that. Zoom in. Huh. I'm going to add that in a different environment, actually. Let me go back to the edit sheet and see if I added it that way. So we're now back into the view editing environments. Okay, so I'm not sure how this cross got here, how to get rid of it, but this is fine. We're mostly in millimeters anyways. You can just get a clean sheet if you want to do inches for some reason. Tolerances, you keep these here. We'll talk about this later on, tolerances and datums. And model by, drawn by, analyzed by, initial date. So for this part, you can do this before or after you finish your dimensioning, but oh shoot, make sure you're always in the edit sheet format. So it's not confused with edit sheet. Add a note. It's like, oh, like I did this. I also did this. I also did, shoot. Also did this. I did all of this and then put some dates next to it, 10/4, something like that. Okay, so you want to make sure all these are here. These can also like automatically propagate, but I think this is just easier to just like add notes onto it afterwards. There's no reason why you had to go through all the trouble of having it self-propagate just 2 letters. You can just enter these 2 letters. These won't change most likely. So if it won't change with your, if it likely won't change these about your part, obviously like you can't change who drew it, right? Like if you drew it, you drew it. So you can just add a note here. But if you were to change the model, the mask changes. So instead of having to constantly go back, oh my God, constantly have to go back to like your part and then evaluate and then check mask properties, check the mask, and then take that mask, go into your part drawing and put it in here, like redo that mask. Is having to constantly change those values. You can just change that in the part model properties, and then this will automatically change along with it. But again, you always want to save a new part model and make a new drawing from the part model. Or if you can somehow make a new part model, save the part file as a new part file, save the drawing file as a new drawing document, and then link those 2 together. So keep your old, the key is you want to have older copies of your drawings and your part models. You want to keep a history so you can always go back and reference them. That's a good habit to get into. Okay, good habit to get into. So let's see what else. can do. Let's go back into the other clean drawing template. Okay, so you don't, as you can see, if you want to have it automatically propagate, you can, but I don't see the point here. This title here is a little bit off, so drag it down a little bit. You can always drag it down in the other file as well. So this is clean, no millimeters. Okay, wait, I think that's mostly it. Oh yeah, revision and drawing part number. Part no, let's go back and change that. In our part model, file properties again. Part model is also something you can just put in as a note block, honestly, because your part model most likely won't change. It's going to be the same part model, just a different revision. So this will change. This you might want to have it automatically propagate, but this part model here, part number, probably won't change. So you don't have to put it as a property. You can just use a note block and make it permanent, or like more permanent than this. Okay, good. And now it should be on our drawing. There we go. Drawing number 11001, revision dash. So once you make a second revision, this will be 1. Rev dash is basically the way of saying this is the OG drawing. This is the first version of the drawing. And you want to keep a history of this revision 1, 2, 3, 4. This doesn't change. This does change. This doesn't change. The company name doesn't change either. This doesn't change, but you should always mark it when you make a new drawing. You should always physically mark it just in case. You would do inches for some other project. You want to have the option to either mark millimeters or inches instead of always just defaulting to millimeters. Initial and date should always have these. If no one checked it, dash dash, initial dash, date dash. I'll just leave it empty. I think that would work too. That would work too, yeah. And again, toggle between edit sheet and edit format. This is a title block, note block, notes block. You don't want to change this or make modifications to the appearance of either of these two blocks in the sheet format editing. In the sheet editing environment, you want to go, you want to toggle into the edit sheet format environment and then make changes to these. All right, I'm emphasizing that because it's very important. So you can always organize this. 10 company, add some notes. H, make that larger. I don't know. Doesn't really matter what we choose, honestly. So sample. Put it in the right side, align it so it looks nice. All right, change that. Copy, paste. Control C, Control V works. Control X, Control V also works. If you hover around here, you can see that there's a pre-existing text box. You can always double click that. Yeah, click that. JC. Nice. Line these two. Line this. Dash. 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 Control C, Control V. All right, so you will need to do this for assignments because obviously, hopefully you modeled it, you drew it. We don't need to analyze or check well, you checked it, but we don't need to analyze it. So you don't need to fill out this section for in-class or homework assignments, most likely, unless explicitly told to do so. But for project assignments, you need to fill this out, this bottom chunk here. You don't really need a company name either for your homework assignments, but for your own project, you might want to just have a group name here or group number. But you'll need drawing numbers for your project, revision numbers for your project. You don't need a lot of this for your homework assignments, but for your project assignments, you do want to fill these out. For your homework assignments, ideally you have at least material and mass filled in here. So for your homework assignments, material, mass, drawing name, drawing title, and then millimeters crossed out. The rest you don't need for homework assignments. But for project assignments, make sure all of these are filled out. Maybe except for finish, because we haven't got to that quite yet. So I think that's almost everything. Oh, yeah. Okay, so toggle back, control save all. Okay. Going to the clean one. Okay, so once you get your template, right, you can play around with it, organize it. You can add more links if you want. We can change the link. You can do, if you don't want to be called weight, if you want to link your own property here, you can. All you can do is go into notes, make a note box first. You always need a note box if you want to display something. And then you hit this, link to property. So you want to click on model found here, and then property name. So you have these predetermined ones. So these are predetermined. However, you can also go into file properties. And once you place in a file, you can go to file properties and click on the new prop. Well, you can just add one right here, right now, actually. So do mass. Okay. Mass. So now, if you label or name your mass number, your variable that contains the mass is called mass, which is sort of like, I guess, intuitive or redundant possibly, or confusing maybe, but I think it's fine. So this way, if you click OK, now whatever variable named mass, whatever property variable named mass, its value will be displayed here. So that's how Milton actually added all these other self-propagating links, variable links. So as I was saying, alternatively, you can also do something like, let me go back, Control Z, Control Z, Control Z. I'll just get rid of it, whatever. Alternatively, you can also leave the page editing format, or rather, after you bring it apart, for example, let's say, as an example, I bring in the same part that I've been working on this entire time. Okay. So the other thing is you might have to save everything before it propagates. So if it doesn't appear right away, don't like freak out. But if it doesn't appear right away, you can always add a new, you can always go into edit sheet format. See, okay, so it appeared. Okay, you can go into edit sheet format, and then again, add it in afterwards. Oh, I want to do a link to a variable name in a model currently found here. file name is the part that I just added, property name, weight. So weight property is what I, is one of the properties that I changed in my part model, check. And then you can always just do space G. And so leave, and this is labeled, perfect. That's what you want. Again, for this finish here, you don't have to add it there. You can always just do delete. You can always just add it in manually. This is always an option, by the way. Add it in manually, silver plated, because most likely this won't change that often anyways. Even if it does change often, it's just a little bit more work. So either way works. Just like many other things, there's more than one right way. Silver plated, there we go. This won't change as you change the property in associated with the model, but again, keep that in mind, just be mindful. You have two options. And possibly even more, I'm not too sure. 7, just to show you what I mean by it will self-propagate and change on its own. Let me go into my part model and change the material. And I'll end off with making a template. Change material. Let's make something drastically heavier. So this is 44 grams roughly, right? I want to make something, let's choose a metal. So it's very heavy to show you that it will change on its own without you having to go back in and change the number from 44 to like whatever new mass value you get. Let's do beryllium copper. Applied, close it. I didn't hit apply clearly. Let's type titanium, pure grade 2, that apply. Hello? Okay, there you go. Control S, save. You're always going to save the file for it to update in the drawing. Come back to the drawing. You can see it not only has this view changed, the material has also changed, and the mass has increased from 44 to 142 grams. So this is what I mean by convenience of like it automatically knowing and automatically changing instead of having to go back and change from 44 backspace to 142.16. But yeah, if you change a dimension, again, save a new file, change the revision number, part drawing number stays the same. Drawing number should be your part number as well. Don't touch the note or the title block without going to the sheet edit sheet format option. So you can always toggle back and forth. It's very important. Make sure to keep these separate. And lastly, let's make a template and then we call it a day. So you'll get a template like this. Start fresh, start new. You won't have this issue. Nothing just forgot to remove a model he had. So you should get something fresh like this, hopefully without all the typos. You have to go into save as. So first of all, oh shoot, hello? No. Oh, okay, I thought SolidWorks cropped out. So new, get into templates here. There's only drawing and WIP, right? This is my old one, but there's only 2 drawing templates. I want to add a custom drawing template. I'm going to add this one to this list. So going to save as. We're going to, okay, so name it whatever you want that you can remember. And then instead of saving it as a drawing, you save it as a drawing template. So there you go, drawing template, and then it'll add to your drawing in your WIP, which you saw earlier. Save as. I'll just keep it as is. Saving will convert the following files to current version. Yep, whatever. Just have to update the version. This is slightly older, probably an older outline. So now if you click this, it's here now. And when you open a drawing template, you get a drawing document, by the way. So you can just select this and then OK. And you're then ready to go and start your career in making these models. All right. So hope this long video provided some insight for you guys, and hope you guys found it useful. I know it was a little bit long, but there was a lot of things to go through. Hope you guys get a better idea of how to properly dimension. Here, let's review everything, okay? Share screen. Wrong screen. So we learned how to make and edit drawing templates provided to you, which will be uploaded. We learned to go over drawing approaches and labeling. Proper and good drawing approaches and labeling. We also went over how to add text, change the text, font size, make it bold, change the style, added shapes, added lines, made a cross, check the box, and how to associate properties and notes, and how to bring in properties using the notes by adding notes to the tool. We went over materials, scale, titles, drawing numbers. I'll upload the PDF of my drawing so you guys can follow along if you like. There's also went over this 2x thing to indicate there's 2 of something, especially holes, very useful for holes, but it can be applied to other things as well. PLSC, I don't remember using that one actually. Let me double check. PLCS. Abbreviation. I think it just means places. If you do 4 PLCS, it just means in 4 places. So I think it's an alternative to using 4x or 2x or number x, but I prefer using number x. Radius to diameter. Oh yeah, radius to diameter. Let's go back into our sketch. Usually you use diameter for circles and radius for incomplete circles, aka arcs. So if I want to change this into a radius for some reason, instead of doing into a diameter for some reason, you can do mod dm. So you cannot. Oh, that's cool. Okay, so you cannot change it. It's just R. If you add mod dm, it doesn't work. It changes to R automatically. I'm not too sure how you can change this to a diameter, but I think there is a way to change this into a diameter or change this into a radius rather. Let's see if we can do that instead. Instead of mod dm, we just add R. Change that to R. Okay, so SolidWorks doesn't let you. SolidWorks automatically assumes if you're dimensioning a circle, it's going to be diameter, and if it's an arc, it's going to be radius. So I'm not sure if you can do that. If you guys figure out a way, go for it. But typically, it is, you should dimension circles using diameters and arcs using radii. And I think that is all. Hope you guys found it useful. And there's hopefully going to be watermarks throughout the video, so you can just jump to certain places. And have a nice day, and hope they helped. Take care, guys.